Hello, everybody. Welcome to the next chapter, which is linear regression. If you remember in the last chapter, we talked about a bivariate correlation, which is Pearson's R. And now we're going to talk about linear regression. Now, these two chapters go hand in hand. And the reason why they go hand in hand is because a Pearson's R, what we normally call a correlation, a Pearson's R is a standardized version of a relationship between two variables, right? Well, linear regression is unstandardized. What that means is that we're still going to look at the slope of a line like we did before, but instead of thinking about it in terms of the relationship between this variable and this variable, we're going to actually have a very specific number. That is, we're going to say, hey, if I have exactly this many of variable x, how many variable y's am I going to get? Let me show you what I mean. So we're really going to be using this idea of the equation of a line. Now remember, y equals bx plus a. That was the same as what you learned back in like middle school of y equals mx plus b, except now we're using the letter b for the slope and the a is the y-intercept, right? So it's the same concept, exactly the same concept. So, well, let's do this. Let's first look at some data. Let's look at some data. Now, if you remember, we had looked at these data before, okay? We looked specifically, let me show you which ones I'm talking about. We looked at these data in the last chapter. So we have 5 participants. This is how many candy bars they've eaten, their stress level, how many days since their last vacation, how many weeks since their last vacation, and then how many fortnights since their last vacation. Now, you should know that the word fortnight is not just a video game. A fortnight actually means 2 weeks. It's a measurement of time. It means 2 weeks. Got it? So let's take a look here. I'm going to make these a little bit bigger. Okay. We're talking about, ooh, not that big. We're talking about fortnights here. I want to know, and let's go back to the slides to talk about this. I want to know if 21 days have passed, how many fortnights do I have? So how many fortnights have passed if 21 days have passed? Now, this is linear regression as opposed to Pearson's R, because in Pearson's R, we would just look at the relationship. What is the relationship between fortnights and days, right? That would be a Pearson's R. But that's not what we're talking about here. I'm looking for a very, very specific number. I want to know, in fortnights, how many fortnights do I get if 21 days has passed? Now, you already know this, right? Well, you're like, gosh, well, if you always have exactly 2 weeks in every fortnight, that means 14 days is a fortnight, right? And that relationship is perfect. It's totally linear, right? Every 14 days, 1 fortnight passes. So if I have 21 days, well, that's 2.5 weeks, right? Sorry, that's 3 weeks. That's 1.5 fortnights, right? Because every fortnight is 2 weeks. That means 14 days plus an extra 7 days. That's half a fortnight, 1.5 fortnights. Now, we don't have to do it just like that. We can do it with this actual equation right here and make sure that we know. In this particular case, x equals days, y equals fortnights. All right? X and y are always going to be 2 different variables. And for us in this class, these are always going to be continuous variables. So x is a continuous variable, y is a continuous variable. All right, now here's what we need to do. First thing we need to do is we need to figure out A. A is the y-intercept. That means y is fortnights. So we're looking for exactly how many fortnights have passed if if x is 0, right? We're just saying, hey, what is going to be y when there's 0 days? So how many fortnights have passed if 0 days have passed? Well, in this particular case, that's easy because it's 0, right? So A is 0. If 0 days have passed, 0 fortnights have passed. That's what the y-intercept means. B is the slope. And you remember the slope is the rise over the run, right? So it's actually the number of fortnights divided by days. So in this particular case, the actual slope is for every day you pass, how many fortnights do you get? All right. So for every one fortnight, for every one fortnight, that's how many days? So it's 1 divided by 14. 1 divided by 14. Rise, 1 rise in y over run. Okay, 1 increase in day. So B, so this is all review from like middle school, right? So the slope is going to be 1 divided by 14, which is 0.0714287. So 0.0714, right? Okay. Now remember, the original question was, if I have 21 days, then how many fortnights have passed? And we already know it's going to be 1.5, right? We already know it's 1.5 because 21 days is a week and is 2.5. 21 days is 3 weeks. Thank you, which is 1.5 fortnights. So we can put this into the equation and get the same idea. So we're trying to figure out y. So b, remember b is our slope, so it's going to be 0.0714 times x. Now remember, I gave you x. I said, all right, I want for 21 days times 21. So I gave you the value of x that I want, plus a. And a in this case, the y-intercept, that's 0. So all we're looking at is 0.0714 times 21. And if I do that in my calculator, guess what it gives me? 1.5. All right, now that's an exact number because the relationship between days and fortnights is perfect, right? It is exactly 14 days pass, 1 fortnight passes, right? It's got a perfectly linear relationship. It's great. All right. However, sometimes we don't have that kind of a relationship. For example, how stressed would you be if it had been 8 weeks since your last vacation? Let's look back at the data. When we look at these data, if you remember, we got stress over here. Let me move this over so we can see both. Stress over here and weeks since our last vacation. Now, these are not a perfect relationship. They're not a perfectly linear relationship. So what do? We don't know exactly what the rise over run is. We don't know exactly what the y-intercept would be. So what are we supposed to do? That's what we're learning in this chapter. Sometimes you don't have a perfect relationship, and you still want to predict how stressed you're going to be if 8 weeks have passed since your last vacation. So in order to do this, we've got to use some different equations. So let's talk about it. So this is where we're going. What you've done in middle school, all that stuff that you did in middle school, that was for a perfect relationship. But now we're not talking about perfect relationships anymore. Now we're talking about y hat. So do you see this y right here with a hat on it? We actually call that y hat, right? What we're looking for is, instead of the actual value of y, we're looking for the predicted value of y. So another thing you should know is that delta means change. When somebody talks about the delta of something happening, it means how much is changing, right? So for example, how much does fortnights change for every increase in days, right? We can actually calculate that. But when we don't know, when it's not a perfect relationship, we have to make a prediction about how much our stress is going to change based off how many weeks have passed since our last vacation. That's what y hat is going to be about. So when we're talking about this in this linear relationship chapter, we're actually not predicting y by itself. We're predicting y hat. We're going to use the same equation of the line, but we've got to do some other math to figure out what the predicted slope and the predicted y-intercept might be. So let's do some review then. All right, here's some review. This right here, that line of best fit, what is that? That's a Pearson's R. Notice how we even have the Pearson's R right here. It is the line of best fit between all these data. Now notice these data are not perfectly in line, right? They are not a perfect relationship. The linear regression would tell us exactly the amount of one for the other, right? And multiple regression is something else. Multiple regression is when you have more than one continuous variable predicting one continuous variable. So in this case, with Pearson's R and linear regression, we're always talking about one continuous variable predicting one continuous variable, right? They're bivariate. There's only two variables. In the next chapter, we're going to talk about multiple regression. All right, another one then. Which of the following is standardized? The answer is Pearson's R. Linear regression is not standardized. Whenever we do a linear regression, we are always asking, I want to know in stress units how stressed I'm going to be if 8 weeks have passed since my last vacation. Pearson's R doesn't do that. Pearson's R gives us a standardized relationship. It's standardized, puts us in z-scores, right? And says, here's the general relationship between weeks without a vacation and your stress level. That is very different, okay? They're both looking at the relationship between two variables, two continuous variables, but one wants it as a general relationship, that's Pearson's R, and the other wants it in exact units in the original unstandardized units. Now, multiple regression actually can give you both standardized and unstandardized. We'll talk about that in the next chapter. All right, so remember, here's our goal. We're going to try and get, if 8 weeks have passed since my last vacation, exactly how stressed do you feel I'm going to be, right? Like in stress units, that's what we're talking about. Now remember, we are talking about Yhat here. We are talking about the predicted value of y. So in the example that I just gave you, x is going to be weeks without a vacation. Y is going to be stress. So what I'm asking is, if I have exactly 8 weeks without vacation, what's my stress going to be? Well, in reality, we would be looking for y sub I, right? The exact value of y when you have the exact value amount of stress when you've gone through 8 weeks without a vacation. That's what we would love to do. But we don't know that because it's not a perfect relationship. So instead, what we're doing is we are predicting Yhat, we are predicting the amount of stress. We're predicting y. We're predicting y. Let's figure out how to do it. Do you remember what we were doing in Pearson's R? Do you remember that in the last chapter of Pearson's R, we calculated a covariance? Well, guess what? In linear regression, we also calculate the covariance in order to find the slope as well as the, well, you got to find the slope and then you can find the y-intercept from there, all right? So we are going to use the same equation that we used in the last chapter, but this time we're going to use it for a different reason. We're still going to find the covariance, but this time we're going to use it for a different reason. So we need to get x minus x bar, that is the deviation. Now in this case, remember, x is going to be weeks and y is going to be stress, so we need deviations of weeks times deviations of stress. We're going to add those up and divide it by n minus 1. Let's go ahead and do that. This is stuff you've already done. What is the covariance? So we want covariance of weeks and stress. So let me just I'm going to move days out of here. I'll move weeks over maybe. How about that? If I can. I'm going to move these over so that we can look at them next to each other. All right. So now I've moved the weeks over. Let's get the deviations for stress and the deviations for weeks and make sure that we know what they are. So to do that, let's make some space. I'm going to put an extra space after stress, an extra space after weeks, and we need to get the mean. So this is going to be the average, the mean. The mean of stress All right, and there's the mean of stress, 7.6. Now we need to do the same thing for weeks. And the average is 5 weeks without a vacation. That is the average. All right, let's move this. I'm going to make these a little skinnier so that I have more room and you can see everything. All right, so this then is going to be the deviation of stress. It's going to be x minus x bar. Okay, actually, I guess in this case is y minus y bar. And this one is going to be the deviation of weeks. Now, how do you know which one is x and which one is y? Well, the one that I give you, I say exactly 8 weeks have passed. That's got to be x. And then what you predict is going to be y. It's the second variable. All right. So let's go ahead and do the weeks since that is x. This is going to be x. So participant 1, it's been 5 weeks since vacation, minus the mean, which is 5. Guess what their deviation is going to be? It's going to be 0 because that's how math works, right? So let's go ahead and make sure that we've got these in the right place. So those are all the deviations. All right. Those are all the deviations that we have for weeks. Now let's do the same thing for stress. It is minus the mean. And particularly, I'm going to keep that mean in the same place. This is the same stuff we did last chapter, right? This is very familiar to you. You've already done this in the past. All right, good. So these are the deviations of stress, the deviations of weeks. Now, if you remember, what we need to do is we need to get the product of those. So what I'm going to do is I'll insert a new one. This is going to be the product of deviations, stress, and weeks. Okay? So this is going to be the deviation of stress. I'm going to make this just a little bit thinner. The deviation of stress times the deviation of weeks. Okay, now we know that that's going to be 0 because participant 1 had a deviation of 0, right? So let's go ahead and do this for all of them. All right, those are all the products of deviations. The deviation of stress times the deviation of weeks for each person. There are 5 total people in this sample. If you look, there's 5 participants, right? 5 participants. 5 participants. So what we're going to do is we're going to get the sum. So let's get the sum for this. It's going to be the sum of the product of the deviations. There it is, 32. That means the covariance is going to be the sum of the product of deviations divided by n minus 1. In this case, n is 5, so n minus 1 is 4. 32 divided by 4 is 8. Now, if you remember, we did this last chapter. In fact, here's our calculations. Let's find the one for stress. Did we do stress in weeks? There it is. Remember? We did this before, right? Okay, we got 8, same thing. We did just the same thing right there. The covariance is 8. All right, now that you found the covariance, the next step is, let me move this up just a bit. The next step is to calculate the slope. Now, I know these look kind of nasty, right? So like this big thing right up here, Boy, that should look really familiar too, by the way. It looks a lot like the sum of squares calculations that we've been talking about before, right? Right? Sum of x squared minus, you remember that? And the product, this looks so, anyway, doesn't matter. You can use either one of these. And since we just barely calculated the covariance, we're actually going to use the second one. The slope is the covariance divided by the standard deviation of x. So the S sub x, that is the standard deviation of x. Now remember, x in this case is the weeks. So we need the standard deviation of weeks since our last vacation squared. Okay? So the slope is going to be the covariance of the two variables divided by the standard deviation of x squared. So let's go ahead and get the standard deviation of x squared. So let's go back to our data. All right, now remember, weeks, that's over here. We already got the mean. So this is going to be the standard deviation. In this case, this is a sample that we're using, right? The standard deviation for a sample for the original 5 scores. Now in this case, I need to scroll up so I can get the original 5 scores. There they are. Okay? So the standard deviation of weeks is 3.39 whatever, right? That's the standard deviation of weeks. This one right here, 3.39165. I'll label it. So that is the standard deviation. Okay? Now, we want the standard deviation squared. So we want this squared, 11.5. So that's the standard deviation squared. 11.5 is the standard deviation squared. So when we're looking for the slope, right, the estimated slope, because it's not a perfect slope, we're taking the covariance divided by the standard deviation squared. So that is going to be the covariance, 8, divided by 11.5, because that's the standard deviation squared. That gives us a slope of 0.6956521. That is the slope. That is the slope. Okay, that is the slope for our specific example. All right, if that is the slope, then what is the y-intercept? So let's go back and look at our data here. So the y-intercept you can get in 2 different ways. The easiest way is to just take the mean of y minus the slope times the mean of x. The mean of y times the slope, minus the slope times the mean of x. So the easiest way to find this is to take the mean of stress minus the slope times the mean of weeks. All right. So let's go ahead and look at these data. Whoops. So let's go to those data. So for A is the y-intercept. That is going to be the mean of y. Remember, what we're trying to predict is stress. So the mean of y is this, it's 7.6, minus the slope, okay, which is b, times the mean of x. And the mean of x in this particular case was 5. Okay, remember 3.39, that was the standard deviation. So I've got 7.6 minus b, the slope we just barely got, which is like 0.65, whatever it is, right? Times 5. This is going to give us the y-intercept, 4.12. Okay? Now what that means is it's the y-intercept when x equals 0. X is the number of weeks. So what we're saying is if 0 weeks have passed since your last vacation, like you just got home from your vacation, we would expect your stress level to be 4.12. That's what that means, right? The day you get back from your vacation, 0 weeks have passed, you have a stress level of 4.12. That's what we would predict. Remember, this isn't perfect, right? It's not a perfect relationship. It's our predicted relationship. Okay, then, if I have been without a vacation for 8 weeks, what do you predict my stress level to be? So, stress for 8 weeks. It's the stress level. It's y hat, right? Y hat is the predicted value of stress after 8 weeks of vacation have passed. Stress is y. Weeks without vacation is x. I gave you x, 8, but we don't know y yet. We have to predict it. So this is going to be y equals bx plus a, right? It's the same equation of the line we've used before. So we need to do y equals bx. So b is 0.695, whatever it is, right? That's the slope, times x. And x in this case is what I gave you, what I said. I said 8 weeks, so it's going to be times 8. Plus the default, right? When 0 weeks have passed, we expect that you have a stress level of 4.12, right? So plus a. So all we have done is I gave you x, right? I'm going to always, in a linear regression, I will always give you x. I will always give you the value of x. And you take the slope times x plus the y-intercept. And we would expect if 8 weeks have passed, your stress level would be a 9.68695. That means we would round it up to a 9.69. That's what we would expect your stress level to be after 8 weeks. Now, do we know that that's exactly your stress level? We do not know. We do not know. We are predicting. We're predicting based off of the data that we have. All right. Let's do another example. Let's do candy bars now. How many candy bars do you predict I will eat if I have a stress level of 12? So, how many candy bars do you predict I will eat if I have a stress level of 12? Now, I gave you 12, so you know that that is x, right? So you know 12 is the actual value of x. X, the variable, is going to be stress in this case. I want you to tell me how many candy bars I'm going to eat. I don't know how many candy bars I would predict with the stress level of 12, right? I don't know. It is y hat. Candy bars is y. And the exact value when you have a stress level of 12, that's y hat. So let's do the same process. First, what is the covariance between candy bars and stress level? So back to the data. Here's candy bars, and there's stress level. Now, luckily, we've already got the deviations of stress going on right there. So let's kind of move this over, and we'll make some space for candy bars. All right, so let's make a new one right there. This is going to be the deviation of candy bars. Now, remember, in this particular case, stress is going to be x, and candy bars is going to be y. All right? So the first thing I need to do is get the mean. This is going to be the mean of candy bars. All right? So that's an average of 5. Guess what? Guess what? Let's take a look. That mean is 5, so let's look at these deviations then. The deviations are going to be, in this case, y, because we've already got an x, that's stress. So y minus y bar, 6 minus 5, right? 6, participant 1's number of candy bars, minus the average number of candy bars, the mean number of candy bars, which is 5. Guess what we get? It's a 1. Big surprise. Let's get it for everybody. There it is right there. These are the deviations for candy bars. Now, we've already got the deviations for stress. That's this stuff right here. This is the deviations for stress, all those deviations for stress. To get the covariance, we need to multiply the deviations of candy bars times the deviations of stress. So this is going to be the product. I'll just do prod and C and S of candy bars and stress. All right. That's going to be the product of the deviation of candy bar times the product of the deviation of stress. Okay, so this times this. 1 times 2.4. So participant 1's deviation candy bars times participant 1's deviation for stress. We do that for every participant. Here's everybody's product. We add those up. It's going to be 24. We don't have the covariance yet, though. The covariance is the sum of the product of the deviations divided by n minus 1. In this case, n equals 5. N minus 1 is going to be 4. Guess what the covariance is? It's 6. Okay, if we know the covariance, then what is B? Now remember, B is the slope. In order to find the slope, we need to know, I'll show it to you again, show you the formula. We need to know the covariance, which we've got, the covariance of x and y, which is the covariance of stress in candy bars, divided by S sub x squared. S is the standard deviation sub x. Well, x in this case is stress. So I need the standard deviation of stress squared. So let's find the standard deviation of stress and square it. Okay. The standard deviation of stress is going to be the standard deviation for a sample. The standard deviation of a sample for 1, 2, 3, 4, 5 of them. Okay? 3.847, that is the standard deviation of the stress. We're going to square that. $14.8. So the slope is the covariance divided by, so the covariance is 6, divided by the standard deviation of x squared. X in this case is stress, because I have an exact stress amount that I've told you. I can't remember, I think it's 12, right? And we will see what we get. The slope is 0.405405. Okay, that's the slope. So what is the y-intercept? The y-intercept, remember, is the value of the number of candy bars you're going to eat when stress equals 0. That's what we're talking about. Remember, x is stress, y is candy bars. So this is going to be the mean of y. Remember, y is candy bars, so 5 minus the slope times the mean of stress, right? Minus the slope times the mean of x. X is stress for us. So 5 minus that slope, which is 0.40, whatever it is, times the mean of x, which is 7.6. 1.918. So basically we're saying you're going to eat 1.92 candy bars when you have 0 stress. That's what that says. That's what that says. Okay, then what is y hat? All right, if you remember, because I don't, gotta go back. I told you what it was. I'm pretty sure it's a stress level of 12, right? Let's find out. There it is. So how many candy bars do you predict I will eat if I have a stress level of 12? How many candy bars do you predict I will eat if I have a stress level of 12? All right. So when we go to these data, I just gave you the stress level. I gave you X, that's 12. And so now we just need the equation of a line. Y hat equals BX plus A. B is the slope, so we need the slope. Come back, that's not the slope. The slope times, make it so we can see. The slope times X, and I gave you X in the question, right? If the stress level is 12, how many candy bars? So X is 12. I have to give that to you. When we're doing a linear regression, I will tell you what the value of X is. Plus A, the Y-intercept, 1.92 candy bars, right? Y equals BX plus A. 6.78. So what that says is, if you have a stress level of 12, I would predict that you are going to eat 6.78 candy bars. All right, thanks everybody.